Welcome to the Ollama Python Library tutorial. In this guide, you will explore the core classes and methods provided by the Ollama Python Library and learn how to use them to interact with AI models installed on your local or remote Ollama service. To get started, open your web browser, go to ollama.com, and click on the Docs menu to access the official documentation and installation instructions. From the Ollama documentation page, locate the navigation panel on the left and click on the link labeled Libraries. This section provides information about the available client libraries, including the Python library you'll be using in this tutorial. Since this tutorial focuses on the Python version of the Ollama library, click on the Ollama Python library link. This will take you to the page containing details, installation instructions, and example code for using Ollama with Python. For this tutorial, PyCharm will be used as the IDE to create the project and implement all sample code examples. After installing both Python and PyCharm, open PyCharm and click New Project on the welcome screen to start setting up your workspace. In the New Project window, enter the project name using Ollama Python package. Choose the location where you want to save it, confirm that the selected interpreter is your installed Python version, and then click Create to generate the project structure. In the Environment section of the Project Setup window, select the Generate New Radio button. This option tells PyCharm to create a fresh virtual environment for your project, keeping all dependencies isolated from other Python installations on your system. After selecting Generate New, click the Create button to finish setting up the project. PyCharm will now create the project folder, set up a new virtual environment, and open the workspace where you can begin adding your Python files. If a pop-up message appears with the Exclude Folders button, click it. This action notifies Microsoft Defender to exclude your project folder from real-time scanning, preventing it from blocking or interfering with your code when it connects to the Ollama service. At the top of the PyCharm window, click on the File menu. This menu provides options for managing your project, including creating new files, opening existing ones, and configuring project settings. From the File menu, select Settings. This opens the configuration window where you can manage project options such as the Python interpreter, installed packages, and environment preferences. In the Settings window, expand the Project section in the left panel and click on Python interpreter. This section lets you view, add, or remove packages installed in your project's virtual environment. On the right side of the window, click the interpreter link. This shows the current Python interpreter assigned to the project and allows you to select or configure a different one if needed. In the package list, locate and click on pip. This built-in package manager allows you to install, upgrade, and remove Python libraries, including the Ollama library you'll use in this tutorial. Click on the Upgrade button. Click on the Add Package button. Type Ollama. Click on the Install Package button. Click Close. Click OK. In the Project panel, right-click on your project's root folder, using Ollama Python package. This opens a context menu where you can create new files, directories, or other project elements. Point to New. Click on Python file. Name this new file example_1 and press Enter. This is where you'll create your first Python script that uses the Ollama library. The file will contain a simple example demonstrating how to connect to the Ollama service and interact with an AI model programmatically. Before writing any code, make sure Ollama is installed and running. Open your command prompt, type Ollama list, and press Enter. If everything is set up correctly, the command will show a list of the models available on your local Ollama service. Here is the list of models currently installed in my Ollama setup. For the first code example, I will use the Gemma 3:4b model. Go ahead and type the code shown in the highlighted section inside your Python file. This snippet demonstrates how to send a message to an Ollama model and display its response. Here's what the code does. It imports the chat function and chat response class from the Ollama package. It calls the chat method with the model name Gemma 3:4b and a message asking, "Why is the sky blue?" The Ollama model processes the input and returns an AI-generated response. The print commands display the model's answer either by directly accessing the message content from the response dictionary or using the structured chat response object. This step introduces the simplest working example of how to interact with Ollama in Python. Click on the Run button. Below you see the results of running your first Ollama Python code. As you can see, the code worked and the Ollama selected model answered your question. Let's create our second example. Right-click on the projects folder. Point to New. Click on Python File. Name the file, example_2 and press Enter. This is where we'll write the second code example of the tutorial, expanding on what we learned in the first one. Go ahead and type the code shown in the highlighted section inside your Python file. This example demonstrates how to use Ollama in streaming mode, where the model's response is printed progressively as it's generated. Here's what the code does. It imports the chat function from the Ollama package. It calls the chat method with the model name GPTOSS20B and the same user message, "Why is the sky blue?" The parameter stream equals true enables streaming, meaning the output is returned in chunks instead of waiting for the entire response. The for loop iterates through each chunk of the streamed response and prints it immediately using the print function with flush equals true, allowing text to appear in real time in the terminal. Difference from the previous example. The first example waits until the full AI response is completed before printing it. The second example prints each part of the AI response as it arrives, making it more suitable for chat-like interfaces or real-time feedback. Click on the Run button. Notice that nothing yet appeared at the bottom. But if you wait, you will see things getting streamed to the console output. Here is another chunk. More chunks. Still streaming away. Still. Keeps coming. Let's create another code snippet. Right-click on the projects folder. Point to New. Click on Python File. Name this new file, example_3 and press Enter. This is where we'll write the third code example of the tutorial. Go ahead and type the code shown in the highlighted section inside your Python file. This example demonstrates how to use the Ollama client class to manage connections and send requests with custom parameters. Here's what the code does. It imports the client class from the Ollama package. It creates a client instance, specifying the server address, for example, http://localhost 11434, and optional custom headers. It then calls the client.chat method to send a message to the model Gemma3:4b, asking why is the sky blue. Finally, it prints the model's response. Difference from the previous examples. The first two examples directly called the chat function, which is simpler but less flexible. This example introduces the client class, which is useful when you want to reuse the same connection, customize headers, or connect to a remote or proxied Ollama instance. In short, the previous examples are for quick testing, while this one is designed for more advanced configurations and integration with larger applications. Click on the position highlighted in the screenshot of this step to create a breakpoint. Now instead of clicking on the Run button, click on the Run Debug button. Once the code execution stops at your breakpoint, the bottom panel will allow you to explore the variables and their values. Click on the right arrow before the response variable. Here we can see several properties returned by the response object. One of them is done, which indicates whether the model has finished generating its response. When done is true, it means the model has completed the response and no more tokens will be produced. In streaming mode, this property is useful to detect the end of the stream so your code knows when to stop reading chunks. In non-streaming scenarios, it simply confirms that the entire response has been received. This property can be used for flow control, for example, when building applications that wait for multiple responses or when managing concurrent requests. The done_reason property explains why the model stopped generating output. When it shows stop, it means the response ended normally, usually because the model reached a natural stopping point, such as the end of a sentence or a stop token. Other possible values can include reasons like length, the model hit the maximum token limit, or error, generation was interrupted. In practice, done_reason helps you understand how the response concluded. It's especially useful in streaming or automated workflows where you may need to handle incomplete or truncated responses differently. Let's expand the message variable. In this view, we can explore the message object contained in the response. It represents the model's reply and includes useful details such as role, identifies who generated the message, in this case assistant. Content, holds the actual text generated by the model. Images, stores image data when the model returns visual output, none here since this response is text only. Other fields like model_config and model_computed_ fields, which are empty now but can contain additional metadata depending on the model and request type. This structure is helpful when you need to extract specific elements of the response, such as only the text content or metadata, for logging, display, or further processing in your application. The role property indicates who is sending each message in the conversation. It helps the model understand the context and flow of dialogue. Common values include user, represents input coming from the person or system interacting with the model. Assistant, represents responses generated by the model itself. System, provides high-level instructions or context that guide the model's behavior during the conversation. For example, in a chat application, you would send messages from the user with role equals user and read back the model's responses with role equals assistant. You can also include a system message at the start, role equals system, to set rules, tone, or context, such as you are a helpful teaching assistant. This property is especially important in multi-turn conversations, where maintaining a clear distinction between who said what allows the model to generate consistent and coherent replies. The model property is the name of the installed Ollama AI model you chose to pass to this request. Let's create another code example. Right-click on the projects folder. Point to New. Click on Python file. Name the new file example_4 and press Enter. Here is where we will type the new code. Go ahead and type the code shown in the highlighted section inside your Python file. This example shows how to use the generate method from the Ollama client class instead of chat. Here's what the code does. It connects to a remote Ollama server using HTTPS authentication. The verify equals false parameter disables SSL certificate verification, use only in testing. The timeout parameter sets the maximum time in seconds to wait for a response. The generate method sends a single prompt, how old is Earth, to the model Gemma 3:4b and returns a simple text-based response instead of a structured chat object. The print command displays the full text output returned by the model. Difference from previous examples. The earlier examples used chat, which expects structured role-based input like user and assistant messages. This example uses generate, which is simpler and better suited for single prompt use cases where conversation context or multi-turn history is not needed. It also demonstrates remote connection and authentication, useful when interacting with an Ollama instance running on another machine or behind a proxy. Before you click the Run button, make sure you have an Ollama installation configured to accept external connections through a reverse proxy. This allows the Python client to connect to the Ollama service running on another machine or server. If you do not already have this configured, follow these general steps to set it up. 1. Install and start Ollama on your local or remote machine. 2. Install Nginx, or another reverse proxy, on the same system. 3. Create an Nginx configuration file that forwards HTTPS traffic to your local Ollama port, for example, 11434. 4. Add SSL certificates if you want to enable secure HTTPS access. 5. Restart the Nginx service to apply the new configuration. 6. Verify that you can access your Ollama instance remotely via your domain or IP address over port 443. Once these steps are complete and the reverse proxy is confirmed to be working, return to your code editor and click the Run button to execute the script. This setup is required because the Python client connects through HTTPS using the host value provided in the client configuration. The panel at the bottom shows the results indicating that the code was a success. Right-click on the projects folder. Point to New. Click on Python file. Type example_5 and press Enter. Here is where we will create our next code example. This code will invoke the list method from the client class from the Ollama library. This method returns a JSON array with properties about all installed AI models installed under your Ollama setup. Go ahead and type the code you see in the screenshot and click on the Run button. At the bottom console we see the result. Notice the array of model objects showing several properties and their values. Click on the Terminal button. For the next example, we will involve user interface into the mix. And for that, we will use the PySide6 library, which is a very powerful library that provides many UI controls and the ability to render a window for our application. Type the command pip install PySide6 and press Enter. Right-click on the projects folder. Point to New. Click on Python file. Name the new file model_list_window and press Enter. Here is where we will type our first UI-based Ollama code. Go ahead and type the code shown in the highlighted section inside your Python file. This step prepares the basic structure for a PySide6 desktop window that will display a list of available Ollama models. Here's what the code does. It imports essential PySide6 components to build the graphical interface, including QApplication, QMainWindow, QPushButton, QComboBox, and QMessageBox. It imports the client class and related exceptions, requestError, responseError, from the Ollama package, which will be used to connect to the Ollama API. It defines a main-window class derived from QMainWindow, sets up the window title, and creates the central widget layout. The interface includes a combo box to display model names and a refresh list button to load or update the list of available models from the Ollama service. This step sets the foundation for integrating Ollama's model listing functionality into a GUI environment, making it easier to browse available models visually. Type the highlighted code into your Python file. This section defines the main window of the PySide6 application and sets up its interface. The code creates a class named MainWindow, derived from QMainWindow. Inside its constructor, ***init***, it sets the window title to Ollama model list. Creates a central Q widget with a QVBox layout to arrange elements vertically. Adds a QComboBox to display model names retrieved from the Ollama API. Adds a QPushButton labeled refresh list, which triggers the refresh_list method when clicked. This part of the code establishes the GUI layout and connects the user action, clicking the button, to the logic that will later handle API communication. This section implements the refresh_list method, which loads the available Ollama models into the interface. Here's what the code does. It creates a client instance pointing to the local Ollama service http://localhost 11434. It calls client.list to request the list of available models from the Ollama API. The method extracts model names from the response and populates the combo box. If no models are found, a message box informs the user that there are no models available. If an error occurs, such as a connection failure or malformed response, the exception is caught and displayed using a critical error message box. This function connects the GUI to the Ollama backend, allowing users to refresh the list dynamically and see all installed models without restarting the app. This final section of the script initializes and launches the application. Here's what the code does. It checks if the script is being run directly by using the standard Python entry point condition if name == main:. It creates a QApplication instance, which is required to manage the PySide6 event loop and UI rendering. It creates an instance of the MainWindow class, which sets up the main interface and widgets defined earlier. The window.show command makes the application window visible on the screen. Finally, sys.exit appexec starts the event loop and ensures the program exits cleanly when the window is closed. This block is essential for turning the class definition into a functional desktop application that can interact with Ollama's model list through a graphical interface. Right-click inside the main block. Select Run. Click on the Refresh List button. Notice that the list has been updated because we can see at least one of the installed Ollama AI models. Let's see if it shows all of them. Click on the down arrow. And here they are, the exactly same list I see when I run the command, Ollama list, I see in this drop-down list. Go ahead and close the window. Let's continue with our pattern of getting PySide6 involved with our Ollama library examples. Right-click on the projects folder. Point to New. Click on Python file. Name the new file, Ollama_ask_questions_async_window and press Enter. Here is where we will implement a user interface app using asynchronous communication with the Ollama service. This new file introduces an asynchronous version of the Ollama model query tool. The script begins by importing standard modules such as sys and asyncio, along with PySide6 components for building the interface, QApplication, QMainWindow, QWidget, QVBoxLayout, QPushButton, QComboBox, QTextEdit, QLabel, and QMessageBox. It also imports async client from the Ollama package, which allows interaction with the Ollama API using async and await for non-blocking operations. This other section defines the main window layout for the asynchronous Ollama model query tool. The main window class sets up the user interface elements and prepares the structure for asynchronous operations. The window title is set to Ollama Async Model Query Tool. A central Q widget with a QVBox layout arranges elements vertically. A QCombo box with the label Select Model allows users to choose a model from Ollama. A QPush button labeled Refresh Model List connects to an asynchronous function using asyncio.create_task, which ensures the UI remains responsive while retrieving models. This part adds the remaining interface elements and connects them to asynchronous actions. Inside the main window constructor, a text input section is created with a label, enter your question or prompt, and a QTextEdit field. The text box includes placeholder text and a minimum height for clarity. A Send to Ollama button is added. Its click event is connected to an asynchronous task using asyncio.create_task, self.send_prompt, allowing the user to send prompts without freezing the interface. An output section is created with a response, label and a read-only QTextEdit where the model's response will appear. This completes the UI layout for the asynchronous version of the tool. The interface now supports entering a prompt, sending it to Ollama asynchronously, and displaying the response, all while keeping the application responsive during processing. The refresh_list method loads the available Ollama models asynchronously so the interface stays responsive during the update. Here's how it works. An async client connects to the local Ollama service at http://localhost 11434, http://localhost 11434. The await client.list command requests the list of installed models without blocking the main thread. When the response arrives, the combo box is cleared and repopulate with the model names. If no models are found, a message box informs the user. Any connection or response error triggers a critical error message box with the error details. Because this method uses async and await, it avoids freezing the GUI while fetching data, ensuring that users can continue interacting with the application during background operations. The send_prompt method enables the app to send user input to Ollama asynchronously and display the model's reply once it arrives. Here's what it does. Retrieves the selected model from the combo box and the user's question from the text field. If either is missing, a warning message appears instructing the user to fix it. Uses async client to connect to the Ollama server at http://localhost 11434. Calls await client.generate to send the selected model and the user's prompt asynchronously. When the model finishes responding, the reply is displayed in the output box. If no response is returned, a default message appears. Any exceptions during communication trigger an error message box labeled Ollama error. Running this method asynchronously allows the user interface to remain interactive while waiting for the model's response, which is essential for smooth, real-time querying. The final section initializes the PySide6 application and integrates it with Python's asyncio event loop. Here's what happens. The QApplication object is created to manage the GUI. A Ksync event loop is set up using QEvent loop, app, allowing Qt and Asyncio to run together smoothly. The event loop is registered with Asyncio using asyncio.set_event_loop, loop. A main window instance is created, resized, and displayed. The loop.run_forever call keeps the application active, enabling asynchronous tasks to run alongside the GUI. This setup allows the interface to remain responsive while executing background tasks such as sending prompts or retrieving models from Ollama. It's the key integration point that combines asynchronous Python logic with real-time user interaction in a single application. Right-click on the highlighted area. Select Run. Click the Refresh Model List button. Keep in mind that it is hard to express the major differences between a sync and an async implementation in screenshots of this tutorial. But if you are following along the steps of this tutorial, you will see the huge benefit. Unlike the previous code samples where we did direct client, in other words, sync calls to the Ollama service, especially for large AI models such as GPT-OSS20B, it freezes up the UI, prevents you from moving the window around, or even minimize it, until the AI model is done responding. In this sample code, we did all using the async client, which releases the UI to do whatever it needs to do and then it signals the UI and the response is done. Click on the down arrow. Here we can see the complete list. Let's select a large AI model, such as the Gemma 3:27b. Click inside the top large text area where we will type the question to be sent to the large AI model. You can type whatever question you want. I decided to use the traditional "Why is the sky blue?" question. The most important thing to notice next is the fact that you will click on the Send to Ollama button, but no matter how long it takes for the AI to signals back its response, the UI will be free, so you will be able to still interact with it, move the window around, resize it, etc. Go ahead and click on the Send to Ollama button. No response yet, but you can freely move the window around and do other stuff without getting the nasty "not responding" message in the title bar. When the AI model finishes generating its response, the application automatically updates the lower text area with the model's output. Congratulations on successfully completing this tutorial. You've learned how to install and use the Ollama Python library to interact with models through chat, and how to send both synchronous and asynchronous prompt requests to the Ollama service, whether running locally or remotely over HTTP or HTTPS. Thank you for following along, and well done on reaching the end of this tutorial.